right. How to test a React application, right? So the problems with testing React applications is people are told to make a bunch of unit tests, and unit tests are difficult because you have to mock things, and you have to figure out the object structure of various third-party libraries. It's not completely unnecessary. We're gonna show you some unit tests, but we're gonna also show some integration tests that basically cover all the bases. And this project looks like this. Right, we gotta wait a little bit for Heroku's free hosting service to wake up my server. Here's the application. We can sign in. We get errors. We signed up. Here's the login with the same. We do this. Right. Done. Undo. Submitting an empty to-do gives us this. Anyways, it's a simple to-do app application with authentication. Then how do we test? How do we test something like that? First of all, we have we have a to-dos and a user aspect to the backend, right? And so that's how the backend is split up. We have middleware, which has nothing to do with anything. Well, it has to do with user, but we're going to leave that by itself. We have to-dos and user. It's basically centered around our Mongoose models. The controllers look like this. But we have an index file here, which is not how things usually work. It's an object with references to the various functions in this folder, the files in this folder, and the reason it looks like this is so that in our app we can import it like this. Right? It's simple, one line, and it gives us everything we need in one line. Not only that, but if you see what's going on here, we've exported our app, our Express app, which we instantiated and then called all the relevant methods. Basically, this is all you need for the app, but we do not instantiate the server here. Instead, we import it here, and here's what we call to actually spin up the server. The reason we do this is that we can require the app in our tests and pass it to session, which is going to spin up a custom server, a custom test server for us to run our APIs on. And each controller looks like this. We import services which are somewhat high level, and we abstract away the various methods we have to call on the to-dos model. And it gives us a nice story that we can just read, easily understand it. Nothing is too complicated. Somewhat simple. The services themselves look like this. The index file imports to-dos model, and we also have a function that we import that we call on that model, right? And this allows us to require in our unit tests pass a mock model so that we don't call it an integration test. That's basically the only difference between our unit tests and integration tests. The services looks like this. This is that function we were talking about. As you can see, we take each of these functions and we call it on the to-dos model. And in these functions is where we call stuff like find by ID or .save on whatever return thing we have. So let's take a look at the tests, right? Let's take a look at the libraries we import. We have Mongoose, right? We don't mock out Mongoose in the integration test. We have object ID, which we use to create IDs. We also use Faker to create passwords and usernames and emails, and lorem ipsum for various, to-do body, which is all overkill, but hey, we're trying to be legit here. Here's our app that we import. Here's our session that we use. We use this to make API calls to the backend, and here's a super test session also. this is a wrapper on this, which allows us to use cookies without having to worry about anything. So let's go down to, let's go into something that we can just talk about real quickly. There we go. Toggle to-dos, close test, right? So we instantiate a session, we pass app to super test. We are going to have an auth session later on when we authenticate the user. We're going to have a return to do, which we're going to pass to a test. We're going to fill it in and then pass to a test as a closure. We have user data, which we're going to use to log in and sign in, and we're going to have to do data, which we will use to create a to do, which we will then toggle the closed attribute and then test the response. Here's what that looks like, right? First, we sign up with our user data, then we sign in with our user data again. We create an auth session, and we send our to-do data to that. We check the response. We make sure it's the same that we sent. We make sure that it's okay. And then here's the actual test we're worried about here. We send an user ID, which is that ID we created earlier. So this is so that we can test that our find by ID method on our mock to-dos model gets passed the right data. We're gonna test that the to-do that this API address responds with has a flipped to-do dot closed attribute, which is exactly what we want. And how does that work, right? You can tell that we're not really worried about the functionality of the actual service here. We're just passing it data, and we make sure that it returns the same data. It doesn't tell us much else, but it is basically all that you need. This tests the whole application because we're not even mocking Mongoose here. We're making calls to the database, and we're checking that it's returning the same data, the data that we need. When we test the services, a test on every single service, because the controllers only use the services, is also essentially testing the whole app, except we're going to mock out the model here, and we're going to see how that works. We're using sign-on, we're using faker again, we're importing the to-do services, which is that function that we call on to-dos, the to-dos model. And how we do this test is we create our ID. Right, we create a save function, which is going to return this.closed. As you can see, we reference it in our to-do object, which has a closed attribute, so we're going to return this data. We create a find by ID function, which is a stub that returns the to-do. Right? Remember, the find by ID on the actual to-dos model is going to look in the database and return the to-do, and that's what we're doing here artificially. We're also going to create a constructor, since technically speaking, a to-dos model is the instance of a class, and so let's be as legit as we can be and create an instance of a class, and we're going to pass find by ID this to that instance as an argument. We don't have to do that. We could have done it by closure, but who cares? You can do it 1,000 different ways. Our services is going to be the to-do services function called on our mock model, right? We're going to call to-do services.toggle closed, which is going to be this function right here. And as you can see, it's going to take our mock model. It's going to take an ID, and it's going to call mock model.find by ID, and it's going to pass it that ID that we made, which you remember. Our find find by ID model always returns that to do that we created in the test. And then we're going to see that here this function flips that to do's closed attribute, and then we're going to call found to do's.save. And remember, our save in the mock model simply returns the to do dot closed attribute. So in the test, we're simply going to check that saved, which returns dot closed, now returns false, whereas before we would have returned true, right? We also make sure that because we stopped it, we can check the arguments that were passed to find by ID, and we make sure that it's the actual ID, right? And there you go. That's what a unit test looks like. We also have an integration test on the models, in which we simply have the database, the real database, and we, we save a to do. We check. We run the, we check that we can find that to do again. We check that we returned the correct kind of errors and all of that. Now let's take a look at the front end, right? And by the way, we have basically the same thing going on in in the user section. It's the exact same pattern of testing, and we have 95% plus coverage for tests in every category here. So let's take a look at the front end, which is the client. Right? Let's look at let's see here. Branch. Here we have React Redux. So with the Redux, a real problem is what to do with the Redux when you're testing your application, how to handle it. And in this case, we handle it kind of similar to the way that we handled the backend. And here's what that looks like. We have a store here, but in the store, we export a function which takes a state and passes it as the second argument to create store, which allows us to have jump around in the state of the application, right? Instead of having to input data, click a button, blah 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 blah, we just jump right to it by giving it an artificial state. And this is useful. Some people will look down on this and say it's incomplete test, but that's fine. It's just a pattern. Let's take a look at the actual test. That's not the test. Here we go. So what does this look like, right? We are going to be using Enzyme. We're going to be using Mount from Enzyme. Here's our to-do app component, which is the master component. So that's the only one we're really going to have to test. Here's our store, right, which is going to be a function that takes state. Remember, we're going to mock out Axios using just.mock. In the back, we're using Mocha. In the front, we're using just to mix things up a little bit. We're going to mount the app wrapped in the provider, right? Over here, we're importing the provider, and this is going to give us a store. And over here, we pass state to the store, and this is actually a function that will take the argument and pass it to the store as the state. So probably you may not have seen this pattern yet, but it actually simplifies the process by quite a bit. Because we're working with asynchronous stuff, we're going to have to use a flush all promises type of thing. What this does is we're placing a this places a function on the callback queue, which is going to be the last one that comes in. So when this resolves, we're going to know that all of the asynchronous functions are resolved because the callback queue is empty, because this will always be the last one. So it's just in case you're confused. This is kind of a hacky solution, but it's the only one I found that works. We're going to mock out Axios in these tests, and we're going to mock out various methods. For instance, we're going to say, Axios.get return us a specific piece of data. Then we're simply going to test if the component displays that data correctly. We can mock out the post request and have it resolved to a specific data also. We can have the component and not pass a state to it. And this is just going to give us our app, as it were. And if we were going to get anywhere in the application to test a component, we have to get there by clicking and inputting data. Or where do we use the where do we have, there we go. We pass a mock state to render, and this gives us a list of to-dos, and then we check that they're there. We check that the first part is what we need, blah 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 blah. This is like the easiest way of testing a React Redux front end that I can think of. We're not making calls to the back end, so it's incomplete. We're also it's not completely functional because we're passing an artificial mock state, and those look like this. See, when we pass this, the Redux store is going to have a list of to-dos, and we can just simply test if these are displayed correctly in the test. It's not a great way of writing a test-driven. This is not a TDD way of writing things, because you have to plan out what your Redux state is going to take in, and then how your components will display that state afterwards. So, but a better way, and maybe not a better way, not a particularly better way, but in some ways better, is this sort of test. Over here we have a giant monolithic test, which goes through the entire application's logic tree, and it only gets there by inputting data, right? Clicking buttons, etc. And we mock out various methods of the component using app.prototype after we mount the app. And this is a much better way of making a React application in a test-driven development manner, because as you're building components, you're adding tests to them in the same order that you're building them. And what does that look like, right? The difficult part about this is that we have to mock out these functions, and they can be somewhat complex, right? But the nice thing about this is that when you're writing the real component method, it's actually almost copy and paste of this, right? It's very similar. The data is going to be changed a little bit. The data is not going to be artificial. It's going to get there via an API call, but it's basically the same thing. And this also has about 95% line coverage. But as you can see, we start out when loading is true, right? We check that whatever we have displayed is correctly. When loading is false, right? That's what happens when suddenly the authentication comes in, and then when authentication is false, we have these specific things we're testing. So this is what your tests are going to look like if you do it in a test-driven development manner. However, it's very difficult to read. It's not that easy to write, but it is going to be really similar to how your actual app is going to look like. And this is without Redux, by the way. This is the pre-Redux version of this application. You can easily write it with Redux. There's a few modifications. And that's basically how you run a test. How I test a React application.